Welcome to the second part of me trying to build an eco board made out of recycled PET bottles, or at least the foam that is made out of recycled PET bottles and linen fiber and other eco stuff. While in the next part I will view all the project again and find a conclusion on how eco this is, see if it works, see if it rides well, and you even get some action shots that I made with my brand new drone. This part is the part of me suffering, having to work hard, having to make hard decisions and sweating, and all in all just not enjoying it so much. One more thing before the video starts. Since a lot of this project is brand new to me and there's a lot of problem solving, there will be certain points in the video where I invite you to mentally join the process and find your own solutions. So at this point you can pause the video, find a solution, and then continue with the video, compare your solution to mine and see which one is better. And I'm happy to see some commentary on that. But now, without further ado, let's jump into the action. The first thing I had to do was cut out the rail belt and the center belt, you could also call the stringer, and glue them on. And this is definitely a part where a lot of weight could be saved, because since I didn't have foam that was thick enough, I had to use about 400 grams of Patex to glue it on. So this is definitely a point where in a future project a lot of weight could be saved. Shit. Okay, as you can see, this seems not to be going well. So all in all, I won't think this will break, because the top and bottom layer will still be very durable and able to take the pressure forces and the pulling forces. But I think that it will be really difficult to make the deck take the forces that it has to deal with by putting the hands on it, putting your heels on it when you're doing a turn. So I'm pretty sure that I make this stiff enough, then I won't be satisfied with the weight. So let's move on to the next task for you. What would you do in my situation? So I consider there are three options. The first one is to quit the whole project, which I almost did, to be honest, because I want to build good boards, and good boards are light and durable. And this maybe would be durable, but not light, or it won't be durable. So there would be good reasons to quit the whole project, to be honest. Option 2 is cheating. Just use carbon on the top shell, and maybe put a layer of carbon here, do the auto lamination with carbon, and I'm sure this would work. And the third option is something I didn't want to do initially, but now I'm forced to do it. I will add something to the construction. So stay tuned for this solution. I'm curious if it will work later on in this video. Mid stringer, and afterwards prepare the top shell to be glued onto there. I will now glue on the top shell with PU glue. This is the fifth component I use. I didn't plan to use this, but this all went a little bit more difficult than I thought. And although I expected it to be more difficult than I thought, I now choose this because I don't want to risk even more difficulties. If this all proves to be working, which I don't expect, then for the next one I would take resin for this. But now I want to maximize my chances of success. Okay, the next day, the top shell is glued to the stringer now. Let's glue on the rails. There. So this was a pretty ridiculous attempt because the top shell was only pressed to the edges of the rail belts, not to their whole surface. So I peeled off all the PU and tried something new. And this is something that you can think about as well. How would you glue on the deck shell? So this was my first next idea I had for gluing on the deck shell. But I realized pretty early that not only the deck shell is bending here, but also the bottom shell, which I don't want at all. And the method I tried after that proved to work quite well. So as you can see, after this pretty huge effort, the deck curve looks quite good and this worked out quite well. Okay, to give you a quick update how it is going, it is difficult, I can tell you. I have two major problems right now. The first one is that the top shell is bent like this, and due to this bending it is quite tense, so it will bend backwards once I take off these pieces of wood, and this will cause the bottom shell to form a V throughout the board, and this is not the bottom shape I wanted. And I didn't expect the top shell to be as tense because I don't know if you can remember, but I was shocked the other way around how wobbly the bottom shell was after the first lamination. So I assumed that this top shell would bend around this form like nothing. Honestly, I have no idea how to solve this. And the second problem is that this is not stiff enough. Even if I laminate over this, I assume that this won't last long if I surf on it. And again, after I laminated the bottom shell for the first time, I knew that this was gonna be a problem. And I knew that the whole project wouldn't work as I expected it because, basically because I don't use carbon and the line fiber isn't as stiff as carbon, and that makes it impossible to copy the construction that AO boards uses with linen fiber. But now I have this problem. I don't want to quit the project. I want to solve this and find a solution. And this is the, I don't know, second or third occasion for you to get into this process and think of a solution. So if you like, pause the video, imagine you were me and think of a solution. Okay, so I think I had an option to solve both of the problems before, but it's too late now. If I had made stringers this way on the bottom shell and on the top shell, it would have been possible to solve the problem with the bending and the V in the bottom, as well as this problem. So maybe that's the reason why so many surfboards are, or the wood surfboards are built this way, with this lots of stringers, and I don't know how it's called in English. How is it called in English? But this Spantenbauweise. That probably would have solved the problem, but I didn't want to do that because this has been done already. So what I will do now is something different. It's a little bit hard to explain, so I just do it and you can watch and make your own thoughts. Afterwards, 3 or 4 hours on maybe 2 meters of this stuff with moderate success, as you can see. I mean, I can use them, I can glue them together again, but it was a lot of work. I finally figured out the way how to do it. And the trick is to invest time in pre-shaping this, as you can see, and then it goes really quick. Stability-wise, it would have been better to stick those sticks through from the other side, because then the deck is supported better. But as you can see, it would have been almost impossible to do a bottom shape with this stuff. Good news! I found a solution for the high deck tension and the consequence of the bottom shell to shape a V, and I will show you. So this is to simulate the deck tension. The great thing is it keeps the shape, as you can see. That's great, isn't it? So now I will just hot air the whole deck and hope that the deck keeps the shape that it has right now. Okay, finally one of the big moments of truth in this process. I will take off the pieces of wood now and then see if my hot airing the surface has done any good. I hope the bottom stays flat on this rocker table. No movement so far. Nice. Seemed to work out well. As you can see, the bottom shell didn't lift up. Maybe 0.5 millimeter, but that's totally fine. And here in the back a little bit. Well, no, when I push down this plate, then you can see that this also goes down to the table. The only shame is that here in the front area, where I used the claws, as you remember, it didn't work out. See? So this is a shame. Now I'm curious about the weight and the stability. Okay, it's already quite heavy. I'll give you the exact weight in a second. It starts to get the stability that I aim for, and it starts to look like a surfboard. Nice. But just as a side note, this is about the status of process where I get to after about 3 hours if I build a surfboard the normal way. With a foam core, hot wiring it, drawing on the outline, cutting it out. And to get to this stage on this EcoBoard didn't take less than 20 hours. Anyway, if you want to see how this whole story ends, want to see me shaping the bottom and the rails and laminating this thing, writing it, then subscribe to the channel and stay tuned for the next video. Bye bye!